Hello DevOps friends! Welcome to Full Stack Live. I'm Jochen, the Monospace Mentor. It's Thursday, time for some live coding. And we're going to continue what we've been working on in recent streams, which is my network simulation / visualization framework based on Dragon Ruby. Yes, Dragon Ruby, a game development framework, will be or is already the basis for my network visualization solution that I'm going to use in my courses and workshops, because seeing network traffic animated and being able to see its behavior with different services that communicate, that filter, that distribute requests, makes things so much easier, makes learning so much easier. And learning is very important to me. That's why I have my side business called the Monospace Mentor on monospacementor.com, where I offer courses for DevOps people, basically. Linux system administration, software engineering, things like that. And one of the courses that I've already started offering is a Varnish course that covers the Varnish cache proxy in depth. It's a course that runs for 6 hours, 2 sessions with 3 hours each. And I would love to have some visual animated way to show people how HTTP requests arrive at Varnish, then get distributed to one of the backends, or even cached and not even going to be forwarded to the backends, things like that. That's what I'm going to build here. And speaking of courses and workshops, we also have a learning community. So if you are going to level up your career, if you are about to change jobs or would simply skill up, then the server room is going to be a good option for you. The server room is my community of practice, where we discuss questions, where we also have lots of events like hangouts, casual chats, or deep dives where I go deep on a specific topic, like for example my own Linux workstation setup here, which is going to be the topic of our first community workshop. That's going to be either, I hope I'll be able to offer it in May. And we also have hot seats where we discuss a specific pain point of a community member, stuff like that. So there's plenty of opportunities to learn, and I'd love for you to check out the different membership levels and see if something is in it for you there. Good morning, Balthazar. I hope you had a good start. How's the weather over there? And that being said, I've also published a new blog post. When you go to monospacementor.com news blog, then there's my latest blog post that was published earlier today. Mastery is mastery of the basics, where I discuss that mastery doesn't really mean all just heavy lifting and being a master of Kubernetes or other things. Oftentimes it's about the basics that need to be honed, and so that's what this blog post is all about. If you'd like to check it out, I'll post it to chat. And I think with that we can actually jump right into coding. But let me see what Balthazar wrote. It's pretty warm. Highs of 30 degrees. Okay. Wow, that is a lot. AC be praised, I guess. I don't mind the heat during the day so much. If I can stay in the shade, that's fine. But I definitely struggle to fall asleep when it's so hot outside. Last year we went to Spain over Easter, and it was already pretty warm. But not as warm enough to cause any issues for me. But I still remember when we went to Ibiza over summer. And I was so happy that we had AC in the room. Otherwise, I wouldn't have slept nearly enough. According to your favorite YouTube meteorologist, it's likely to be an active hurricane season this year. Well, batten down the hatches. 18 degrees is fine. 18 degrees is fine. Lose the duvets and you're good. All right. So, temperatures are maybe going to be a problem that I'll have to solve eventually. We just learned earlier today that friends of ours who they are from Spain and just bought a house over here in Ireland 1 or 2 years ago, but now they are moving back to Spain. And Spain was already at the top of the list of countries where I can imagine myself living because of warmer temperatures, less rain, definitely less rain. I also like the food, and I've started learning the language. So our friends moving over there later this year as well is another drop in the bucket. And I don't think we'll move willy-nilly, but let's wait and see if our landlord is going to renew our lease again. If that's the case, then we'll stay. But I think a move to Spain will be imminent the moment our lease over here doesn't get renewed. Spanish real estate is, as far as I know, I haven't looked into it very deeply, is similar to other European countries where it's definitely heating up. But if you don't want to live in the major cities like Barcelona or Madrid, there's still ways to get something. And since we are used to high rents anyway, even if we have to spend the same, we'll get more footage over there, definitely. As far as what I heard was they are going to live in a town between Valencia and Barcelona, and I think it's a 5-bedroom house they're going to rent over there for €1,600. It's not a little amount, but for 4 or 5 bedrooms, it's plenty. It's perfectly okay. Yeah.
Flush the bombers, get the subs in launch mode. We are at DEFCON 1. DEFCON 1?
Oh, I was just about to get started, and then TBD Gamer comes in with all his raiders. Welcome, raiders, especially TBD Gamer. How's life? How was your stream? Let's defend the channel, folks. And of course, raiders, feel free to attack it. It won't amount to much anyway. Yeah, I was just about to get started, actually. So what I am going today is to continue my work on my visualization framework. Visualization what? Yeah, So, if you're not familiar with what I do, I'm Jochen, the Monospace Mentor. I do courses and workshops and all kinds of educational content for DevOps people, especially for juniors. And in that capacity, I'd love to have something that allows me to simulate network interactions, where I can actually say, good, I have a client, a HTTP client here, and a HTTP proxy there, and a cluster of application servers there, and let's visualize how traffic flows between these machines, and what happens, for example, if we flood the load balancer with requests, and stuff like that. And I was wondering how I would be able to build that, because I'm not an animator, and doing this by hand was out of the question immediately. It took me probably half an hour to simply animate a request moving from a client to a server, so I didn't even dare to think about animating traffic in a whole cluster of machines. And then I realized, well, how about we use a game development toolkit? Because, I mean, what's the difference between a bullet crossing the screen, slamming into a wall in an explosion, and a HTTP request slamming into a server and getting processed there? There's not much of a difference, is there? And so I said, let's take another look at Dragon Ruby. I did dabble in Dragon Ruby a few years ago when I bought my license, but I never went far. And so I reinstalled Dragon Ruby and did a few live streams now where I built stuff. And let me show you the result. But something else that I'm going to do at the moment is I'd like to test out RubyMine just to see how well it works for me. So I might actually switch to RubyMine for good when it comes to Ruby development, but no worries, NeoVim will always be there when I need it. Let's close that terminal and let's use RubyMine here. Can I make the font a little bit bigger for you? No? That does not work. Is there a zoom button or anything? Otherwise, let's simply go into the settings. Editor, font. Or is there zoom? No, appearance. Yeah, there is a zoom. Let's pull that up to 125. That should be better for you, shouldn't it? Oh, nice. Yeah, that works well. So, how does this look like? Well, let me show you. Let's maybe start with a simple visualization. Where's my main setting here? This is my main model class where everything starts. So here we set up a round-robin load balancer on which we are going to work later, and a bunch of receivers that get the requests from this load balancer. And down here we have a few methods that simply provide the settings. For the whole model, we have 3 receivers, or 3 servers. And let's simply start with a processing time. Let's leave it like this, but we'll have a sender spawn time of 30 and a maximum of 30. All these are basically frames per second, so 30 means half a second, because the game will always run with 60 frames a second. And TVT Gamer shared, stream is good, just hit it. Oh, that design is probably wrong moment, so probably back a couple of weeks of dev. Well, I am experiencing the same here. Even though it throws us back a little bit, it also means that we had a learning moment and can improve our code. So it's not for nothing. So what this is going to do is it means our sender, which is also the load balancer, will send a request every half second, and it'll be distributed between the 3 receivers. And as it says, round robin load balancer, it will distribute these requests to each receiver at a time. So let's save that and start Dragon Ruby. Boom. And here you can see nothing. Okay, you can. Okay. Here you can see it sends the requests, which are these blue little squares, and each of the receiver processes them. These receivers have different processing times. This one has 52 ticks, which is almost a second. 38 ticks is a little bit less, and 47 is in between. That means this left one here is much slower than the other ones. And this would be a problem if we had more requests coming in. Since there's only 1 request every half second and we have 3 receivers, every receiver only gets a request every 1.5 seconds, or 180 ticks, and all the processing times here are far below 180, so all of them have a success rate of 100%. All these labels here are things that I added after the last stream on Tuesday, and so we can just see how things work here. What we probably have to do is we need to pull up the request rate, and then we'll see that things will change. So let's set the minimum spawn time to 10 ticks. That also will require a restart of our simulation, so let's start this fresh. So as you can see now, sometimes these requests go out in bursts, and all these receivers are pretty slow. And as you can see, while they are busy, while this green clock is running, the requests will be dropped. These are the red squares that bounce off. And as you can see, we have different success percentages. They're all pretty equal because their processing times are all pretty equal. But I can re-randomize that. So now we have a one here that is pretty fast with 25 ticks. Here 30 ticks, just a little bit more, but this one is half as fast or double as slow. And this is definitely reflected here in the success percentages. While these two have 90% success rate, this one just has 75. And it'll probably be even more distinctive over time. And yeah, so that's my simulation. You can see I can change the different spawn rates and also processing times if I don't want to randomize those, and see how the behavior changes and what happens, for example, if we add another receiver. So let's up the receiver count and restart the simulation. Now we have 4 receivers. And it takes quite the burst of requests to make them fail. These two on the right here with 12 and 18 shouldn't have any issues. And here, well, yeah, the 45 will definitely not have as much success as the 28 one here. Jim over on YouTube, welcome! DevOps consultant specializing in infrastructure as code, deployment pipelines, integration scripting, Python. That sounds great. Sounds like fun. Good to have you. Welcome to the stack. Yeah, so as you can see, with 4 machines that are decently sized and have decent performance, we can easily deal with these bursts that previously were problematic with only 3 nodes. What I'd like to do is to make this simulation a little bit more interactive, so we can change the setup on the fly without having to restart the simulation. I would love that. And we need to also refactor the code a little bit more, because now new classes are materializing, and I realize where my design is falling short. And that's what we're going to do now. If you have any questions, if there's anything that you'd like to ask or to share, please feel free to post it to chat, and I'll do my best to answer your questions. This is definitely a learning channel, and well, I am learning a lot on this channel, and I hope you'll be able to too. Okay, so we'll keep the simulation running just to your entertainment, and I'll go and let's see. So something that I'd like to fix is here we are using a round-robin load balancer class, and it's the load balancer itself that spawns requests. That's of course not realistic. I started with the random request emitter up there, but when I said, okay, let's implement the algorithm for the distribution of requests, let's make that round robin, which meant that I had to create something more specific and less generic. And that's when I created the round-robin load balancer. But I realized we should actually have a client or the internet down here that submits these requests, and they all go to the load balancer, and the load balancer then only forwards them onto the machines. Just a second, my wife is calling me, so let me grab that quickly. My wife reminded me that she won't be home in time for our son to open up the door for our son, so I'll have to probably open the door in a few minutes' time. Alright, so where were we? Yeah, split up the responsibilities here. Load balancer should only balance but not spawn the requests them in itself. So yeah, we'll move a few things into this random request emitter here. And let's see where the differences are. Yeah, it's not as far developed as the load balancer, so we'll simply pull out stuff from the load balancer and add the random request emitter here. Let me see. Let's start by putting the random request emitter below our load balancer so that we can already see it on the screen. That means where we, in our model where we initialize all entities in this simulation, we'll have to rename this create sender into create load balancer, which is the more specific term here. And that's why I'm trying out RubyMine, actually, because RubyMine has these refactor automations built in where I can, for example, say, rename this method from create sender to create load balancer. And there's the... there's a preview. Interesting. So I can see where the instances are that will be modified. I guess that's okay. Refactor, and here we go. So we need to create a load balancer for with the receivers we created before, and of course we need to create a load balancer instance that will then use in create emitter, which we'll still have to write. We'll do that down here. Create emitter. We'll call it target or targets. No, an emitter can only send requests to a specific machine, I would say. So we'll simply call it target. And that basically will look like emitter equals random request emitter new, and we'll have to pass in our engine, which is ourself, and then we'll add the entity that is the emitter. Entity is the most generic part of our simulation. We'll add this entity to our simulation, and that should then create this random sender or emitter. And this should actually work. Let's give it a test. Oh no, it didn't. Yes, it tries to create the random request emitter, but it's buggy. We need to now update everything. So this round robin load balancer will not spawn requests anymore. It will forward requests at a later time, but the spawn requests call here needs to go to the random request emitter, where there is already one. Okay. Oops. And then, of course, we'll also need a spawn request method that needs a spawn condition. And we'll have to initialize it with specific details. So the spawn min and max values move out of the load balancer and into, oops, I need to get used to how the navigation works in RubyMine. And that's why I'm actually not using the split keyboard that I had been using earlier today, because that would have only confused me even more after I've changed the keyboard layout a little bit. So that's this. And of course, we need to initialize it with these values. So let's go back to our simulation model. Here we create a round-robin load balancer with a position. And yes, we need to pass in a position as well. There's also an ad break coming up. Ideally, my son will arrive just during that break. So we need these receivers, but we don't need the spawn min and max values. Those need to move to the yes, here's my son, so let's take a short break. I'll be right back. That was perfect timing, but let's wait for the ad break to finish. So people don't miss much. Let me see. Simulation line 83. In simulation, okay, but it's network endpoint, random request emitter 13. Yeah, because we don't have any position. So I think an endpoint or even an entity, since endpoint is an entity, should initialize its position to 0 if there is no position defined. That way it'll at least work and not completely fail. I mean, 0, 0 will then move it to the lower left corner, but that's fine. So let's take a look at entity. Where did we define entity in the first place? There's no entity. Ah, that's in simulation.rb. Oh, we need to split this up as well. Yeah. So let's simply add this here. That way it's at least initialized, even if not really workable. Let's see if I restart. We are still running into problems. There is a method name pick receiver doesn't exist. Yeah, we moved a little bit of load balancer logic to our emitter accidentally, because receiver is defined as pick receiver, and that's the algorithm that the load balancer uses to determine which of its backends it's going to send the request to. And in this case here, we'll simply use @receiver, because I think that's what we pass in. We pass in receivers. Yeah, an emitter can't have multiple targets. That doesn't make sense. Otherwise, it would be a proxy or something more sophisticated. So let's call it receiver, which means we can then use @receiver here. And now we are missing a method named centerx on probably the random request emitter as well. Sanmashi, welcome to the stack. This is Ruby. I'm a Ruby developer in general, and what I'm doing here is I try to build a simulation for network traffic that visualizes requests passing between different services and servers, and I decided to build this on the basis of the Dragon Ruby game toolkit, because it'll make things so much easier in terms of animating stuff. And so basically it's a little bit of game development, but for a more serious reason, because I'd like to use these visualizations in my courses and workshops. If you have any questions, let me know. Okay, so we are missing centerx on a nil class. What is nil here? Network request, line 14. Yeah, I guess the request here gets initialized with the wrong information. Let's see, request RB in line 14. Yes, we try to determine the speed for our requests to travel across the screen, which is the receiver x coordinate minus our own. But since the coordinates usually for these objects are the lower left corner, I've introduced methods called centerx and centery to get the center coordinates, and our random request emitter doesn't have those. The random request emitter, being an endpoint, should have them though. Doesn't endpoint not have the centerx method? Yes, it does. Then what's the problem? We are calling centerx on a nil class. The receiver is nil. Is that the case? Apparently it is. Let's go back to request. Here we call receiver centerx. Yeah. If this call fails, that means receiver is nil. That means we are initializing our... Oh wait, the request? Yeah, we are initializing our request emitter wrong. I'm sure I'm emitting Balthazar, but I think it's a naming issue here. Yep. Let me see. Where's the emitter? We don't even pass in a receiver. If you don't pass in a receiver, that should basically get caught by the request emitter itself. So let's take a look here. I mean, the easiest way to do this is to say fail, no receiver defined. that should solve this problem. Let's see. Let's go back. Where do we... Here. But I need to familiarize myself with the keyboard commands here as well. And here we have a runtime issue. Oh, there's a syntax error now. That's not what I meant. Random request emitter has a syntax error in line 7. Yeah, that's the fail, isn't it? Shouldn't this work? Otherwise... Oh, you know what? If we use fetch instead of directly trying to access the key, then fetch will automatically fail if there isn't a key. Yeah, fetch is the better way to get these values. That has this safety net built in. There's still in random request emitter line 10. Oh yeah, we're missing a parentheses. Okay, now it doesn't fail. Doesn't fetch fail? Something I have learned recently is that I can't take for granted that everything works as I'm used to, because Dragon Ruby is using mRuby as its core engine. And mRuby is built for embedded systems and for high performance. And so there are distinct differences between the MRI Ruby that I'm used to, the common main Ruby version, and mRuby, which is built into Dragon Ruby. So maybe fetch doesn't work as as I expect it to, but let me quickly verify that my instinct at least is right. If the key can't be found, there are several options. With no other arguments, it will raise a key error exception. So that should actually happen. But maybe, yeah, the semantics are different, or the behaviors are different in mRuby here. Okay, let's put this to the side. These more defensive things, we can take care of those later. Let's simply do what we're supposed to do and pass in a receiver, which is our target argument. Praise be to the mute button. So no, still doesn't work. We create an emitter by creating a random request emitter, passing in a receiver and our spawn parameters, and still in network request initialize line 14. We are still running into issues. Let's use fetch here. That's strange. Let's try a little bit of debugging. So inspect simply returns nil, so that is of course not very helpful. Why is it nil? Request gets called by random request emitter here, where we pass in our receiver value, which gets set up here. Let's see. What happens here? That's nil already. Okay, so when we spawn random request emitter, we're passing in target. Which is also nil. Create emitter. Gets called with load balancer here. Oh, yes, of course. Yeah. What I did earlier was before I simply created the load balancer and I didn't need the object instance in any way. So I didn't assign that to a variable, and then when I started pulling stuff apart, I simply assigned the create load balancer to a variable, and now I'm starting to use this variable. But create load balancer doesn't even return a value. Create load balancer down here uses sender internally, but doesn't return it. And I guess it's actually a good idea to add these comment tags, and that's also very helpful that RubyMine offers these. So we have the object receiver, yes, and that is actually it's not an object, it's an array. A list of receiving endpoints. And then we have a return of a round robin load balancer. The LB entity. Okay. Now, create load balancer does now return this, but we might actually have to restart the simulation. Ah, yes. It worked for a few seconds, and then it broke. Let's see what happened. Yeah, the method named connect doesn't exist on round robin load balancer. Oh, look at that. Of course, yeah, our request emitter started sending requests from the lower left corner here, and they took a little bit of time to reach the load balancer, but eventually they did. And now these requests wanted to connect to our load balancer. And of course, our load balancer doesn't offer that yet because it never was built to receive requests as well, because the sender was built in. So let's see, where's our load balancer here? We'll have to have a connect method, and for the time being we'll simply return false, so it'll reject all requests because it can't handle them anyway at the moment. Sounds pretty secure, says Balthazar. Yep. A load balancer that only sends requests sounds pretty secure. Yeah, it does. That's why we are making it less secure now. Okay, so here's our sender bombarding the load balancer with requests, and they all bounce off. But isn't it great? We just had to create this connect method that returns false, and the requests that have already been coded simply do their stuff. And so I really love that. I love this framework that I'm building here, and the object-oriented design around it, because it makes things so easy. Because these requests, when they arrive at their target, they simply try to call connect, and if that fails, then they'll bounce off. And yeah. In a perfectly secure system, no one would be able to do anything. Murdoch, preventer of information services. Yeah, the perfectly secure system will be a server that is switched off and encased in a box of concrete. It's just not very useful. What's the... Trading white space? Yeah, fix that. We don't need any white space there. Okay, obviously the position of our sender is off, so let's fix that. We did not even care to pass in coordinates. The X coordinate is going to be the same as our load balancer up here, which is 615, and pause Y, then we'll put this at 100, 615, 100, pause Y, 100. Let's restart this. Yeah, that looks much better. Okay, a load balancer that, oh wait, there's another glitch here, because we are rendering the spawn values in our load balancer, which doesn't have any spawn functionality anymore, so that will have to move to our random request emitter as well. Let's pick this up where it is. That's in render. Here we have that, and that goes in the render method. Of our emitter. And of course, we'll have to also call that from our central tick method that gets called for every entity on the screen, every frame. And now we've broken something. Yes, because we need to pass in our arguments as well. And we've overwritten the render method of our superclass, which is why it doesn't render its border anymore. And now we have our border back. Okay. Ah, okay. I did not get that. I thought Murdoch Preventer of Information Services was out of the BOFH. Yeah, but it's actually Dilbert. Yeah, you're right. And yes, Dilbert is definitely problematic, which is why I don't have my Dilbert on display anymore. And that's why it's down here on the trash pile. Bethesda says you may want the load balancer to still show some of that if you decide to model health checks and such. So I'd test to see if parameters for emitting requests are set, and if not, do not render. That's a good idea. We'll see. You used to tag yourself BFH? Of course you did. We all should have. Alright, now let's teach this load balancer to do something a little bit more productive. So I'll steal the spawn request method from our random request emitter, because why is render a private method? Should it be? No. No. I feel better having it as a public method. What's your problem? Useless method definition? Oh, because it just calls super. Yeah, Rubocop is right. That's completely useless now. Which renders the question if it should be private or not moot. Moo, hello! Long time no talk. Alright, so what our load balancer is supposed to do is to, well, let's start with returning true, so it does actually accept the request. And of course, for each request that it accepts, it needs to create a request of its own. So we'll call spawn request. So we could have left the spawn request method in here. It'll just need to be stripped down a little. We have no spawn condition at the moment. And once we implement some conditions, they won't be spawn conditions. So if we actually want to spawn a request, we'll do so. We'll use our pick receiver method, and that's it. Returning true means that the original request will be terminated. It'll live for 5 more ticks or something, and then it'll die. And so the request on screen, I mean. And the load balancer will then in turn create a new request. And maybe we should make request colors variable here as well, but we can do that anytime. So let's see if I can actually save this and already see something except an error message. Args doesn't exist on... wait, what? Yeah, connect. Connect. Oh, okay. Mm-hmm. We do need args, don't we? No, we don't. Oh, yes, we do, because we're using args here. But, do we really need it? I mean, we could... I think it's time to get rid of this name attribute. We needed that for management of our entities in the beginning, but it's become obsolete and now it's becoming an obstacle. I mean, Balthazar, it probably should say telling everyone no on a daily basis, because, hey, Managers need to be told no as well from time to time, at least. Yes, if args is if the only reason that we need args here is that we can actually create this name, I don't really care for that. Okay, good point. I see what you mean. In the end, people are users. Okay. I did not see that inheritance between people and users. They are related classes. Yeah, let's get rid of name, but that means we also need to change our central simulation class. That still depends on the name for its management, so let's remove that. And I guess there are a few... Wait, that's the entity. Entities don't have names anymore. And the simulation will now manage its entities in an array. For the time being, we'll use an array. And so we can do entities each. And call entity tick. Add entity means we'll simply add the entity. Oh, we need to be able to remove entities. That complicates things. F word. How do we quickly find an object in an array? I have an idea, but I don't know if it's a good idea. Retrieve specific object from array. Yeah, it's not about finding a value in an array, because that will always have an order of n. Ruby find and return objects in an array based on an attribute. Yeah, if you're based on a specific attribute, you should use a hash. I guess that's the answer to my question, though, because, yeah, if I want to remove entities with an order of 1, I need to have an identifier, and I still need to be using a hash. So let's actually fix that. It's just not the name, I guess. Ruby use object ID as hash key. Yeah, that's more like it. Okay, we could... Actually, yeah, I don't know why it's downvoted so much. because basically, yeah, we need to find a hash key for each of our objects. Let's say, an often overlooked feature of Ruby's hashes is that you can use any object as a hash key, not just strings and symbols. OptCarrot, the Ruby NAS emulator, uses this feature to optimize its mapped memory implementation. Yeah, I think we are onto something here. OptCarrot does it. Wait, a reading write to memory, depending on... could reset the joystick, implement this in Ruby. Okay. Creates a lot of individual method objects that are identical. Oh, there's an object ID. I think just using the object ID could be a good way to start. Let's give this a test. Let's say class foo. Class module name must be constant. Yeah, of course. Class foo end a equals foo new a object ID 240, whatever that means. B equals foo new object ID 260. Well, it's unique, I guess. No idea what the algorithm behind it is, but let's see how this works. So we'll use ID here. And you know what? If you're dealing with entities here, we'll use entity ID as a method. And that allows us to define this ID or this hash key, whatever it's going to be, inside entity, which will need its own file soon. Why not now? Well, let me see it work. Engine initialize. Okay, so def ID object ID. Okay. What, grid? No, not grid. What are you doing? Okay. Method args doesn't exist. Yes, we don't need args anymore. Where is that? Round robin load balancer 19. I think that was, yeah, okay. It lives! We should change our model parameters though. Where are they? Down here, sender spawn rate. Let's make that 30 for everything. That did not restart the simulation though. Let's see. Now we can see that we are still doing round robin. Isn't it amazing? I didn't have to change much in terms of business logic. I'm just accepting the requests, and then I create my own requests according to the load balancing algorithm and pass them on. And that's all it does. It's so great. Once you have a working object model, stuff just falls into place. And all the other stuff that I had to do was just refactoring because of shortcomings in the internals. Awesome. Again, very happy about this. Hey, Pennywise, how you doing? What I'm doing is I'm building a network simulation / visualization. So here on screen you can see a setting where we have a sender that sends requests on a constant basis at the moment. And here we have a load balancer that uses the round-robin algorithm to pass these requests on to 4 separate machines that have different performance characteristics. So this one here takes double the time to process requests than this one here. And only because the requests are coming in so slowly, all these servers still have 100% success rate. If I change that by setting my spawn minimum to 10, things could become much less nice quickly. But unfortunately, these changes don't reflect in the engine yet. That's another feature that we'll have to build in, that I can change parameters of the simulation on the fly and stuff just adapts. But for the time being, I'll have to restart the simulation. And yes, we have a very fast server over here. I'd expect that to be at 100% all the time. And we have 2 very slow servers over here. And they only have about 60% success rate here, because requests get dropped a lot if they come in a higher frequency. Mu asks, can I integrate this into Varnish log now so you can have a live visualization? Not sure if Dragon Ruby will hold up, but we can always try. You built something like this yourself. Okay, yeah, you mentioned you did something like a network simulation. nsnam.org. Let me see what that's a simulation software, isn't it? So let's see, nsnam.org. Doesn't exist anymore apparently. Oh, it doesn't need the... Okay. Network simulator. Discrete events network simulator for internet systems. Yeah, I can see myself building something like that at the moment. Maybe I could have used this one, but it would have been half as much fun. And it's much more sophisticated. It's really for simulation, I guess. It's not exactly what I'm looking for. Oh, nice to see they have a Zulip chat room. We do not use Discord, Slack, or IRC, but Zulip instead. Kudos! Kudos. Let me see. Are there any images? Open extensive network simulation platform. Yeah, I guess that's would have been complete overkill. But yeah, as Pennywise says, the schedulers is exactly why I wanted this simulation, because at the moment it does round robin, but as you can see now that the simulation has been running for a while, our fast server here has a success rate of 99%, which is great. Even the 93% here is great, but these two with 75 or 72%, that's just not acceptable. They basically drop a quarter of the requests they get. And so round robin definitely isn't ideal if you don't have identical backend servers. And so that's exactly what why I've built this in an object-oriented way and didn't visualize it with the primitives that Dragon Ruby gives me out of the box, because I want to have systems that behave similarly, but not identically, because yeah, I just thought how I could create a more generic load balancer. And have round-robin load balancers be simply a specialization of that. I think what we can do is actually we can take round-robin load balancer and I'll rename that to load balancer. What would a generic load balancer do? Nothing, I think. It should be an abstract class. So let's duplicate that. Can we do that? We can delete and we can copy. So we'll call that load balancer. Oops, didn't mean to do that. Again, paste. Okay, do you want to add the following file to Git? Yes, add it. That's a nice feature as well, so we don't forget to include these things. Load balancer itself will have all the necessary logic. Of course, it needs to be renamed here. We have receivers. We don't have any round robin though. And the only thing that's different is we'll fail with abstract base class when we try to use this load balancer. But that then makes building our round-robin load balancer much easier, because we can inherit from load balancer. All we have to do in our initialize method is to set our round-robin cursor. Tick doesn't need to be defined. Connect doesn't need to be defined. Spawn request doesn't need to be defined, and the only thing that we need to define is pick receiver. We need to override that and return our receiver, and that way we've built our round-robin load balancer. It's a load balancer that simply cycles through the available receivers, which does simply fail because we need to include that load balancer file in our network. So like this, and then things work again. Which means we can now build another load balancer that has a different distribution algorithm. like weighted round robin, for example. And that's going to be just as easy, because all we need to do is basically implement the pick receiver method here, and that's it. Which is great. And I think that's a good point to commit stuff. What did we do? We refactored a lot of stuff. Yeah, it's mostly refactoring, right? And we've added the emitter. Okay. Extract emitter from load balancer and refactoring. Cool. Oof, why is it so hot in here? Is it so warm outside? 15 degrees. All right. Okay. I live in Ireland, a little bit south of Dublin. And I've lived here for 14 years now, since I moved here from Germany. And as I mentioned at the beginning of the stream, the likelihood of me moving to Spain has just increased earlier today, when we learned that a family of friends is moving back to their home country, Spain, shortly. I really like how this looks. I'm sorry if it sounds self-congratulatory, but I'm just happy with how this looks like, because yeah, maybe it's mostly because I thought it would be a lot more complicated. This, I could watch this all day. You're perfectly right, Balthazar. Thanks for that. Thank you for the kind words. Now, something that let's get underway to being able to reconfiguring this simulation on the fly. And I think what I'd like to do is, for example, being able to add or remove cluster nodes on the fly. So we can, for example, see how a single application server gets overwhelmed quickly, and then we can press plus or something, and then we'll get another one. And not only should we get another one, they should also rearrange on the screen. And I think it would make sense to create something like a cluster class that takes care of the positioning of these nodes and things like that. At the moment, it's the simulation itself that takes care of centering them with in an equidistant way, but I think we should have something like a cluster that can then also return the number or the list of its cluster members, which will also simplify things a little bit. So yeah, I can imagine that. So let's create a cluster class. Oh, do I have to type that in? That's not even... Is it? Okay. Class cluster. And we always need an engine, and then we'll have a bunch of attributes. We'll call super, and cluster will of course be an entity, which means it's a simulation entity. Simulation entity. And we'll have an array of members. And so we'll have to have an add member. How? Where did this autocompletion come from? No, it can't have AI built in, can it? I didn't have to register anything, and I don't think it'll be free of charge and built in. Anyway, remove member will be harder, so we'll use the same logic. We'll make members a hash. And so members member.id will be assigned member, and remove member means we'll delete add members member ID. And now for the more interesting stuff, we'll need a render method that displays our members. And we can steal that or move that out of our simulation, because that's exactly what this simulation does. Here we have a list of receivers, and we distribute the a space that's 800 wide, 800 pixels wide, and we'll distribute that evenly between our members. So let's copy that for the time being until we are ready. So we need something like render members, and I guess render will always have to get args passed in. And so for render members, we'll say, okay, let's start the same way as we did it before. We'll distribute our space between all the members. So we'll need a member count, which is basically just it's not an array length because we are... Does hash have a length method as well? I mean, Ruby does keep track of the number of hash elements, I guess. Let's see if that actually works. Members length. So, we'll call it member space and member offset based on member space. The width of 50 that we are using here needs to become variable. That will not work for bigger elements, but let's keep it as it is for the time being. So that's that, and then we'll go through our members. And position them accordingly. Add entity isn't necessary. Add entity means add this entity to the simulation, and when we are done this part here, we'll simply create the cluster and then add the cluster as an entity, while the cluster... Yeah, things are getting more complicated now. That also means that the cluster needs to manage its members. Yeah, but it does. Pennywise, thanks for stopping by. Have a great Thursday. So, yeah, we'll say members each pair ID member. You know what? We don't have to calculate that for every tick. We just have to recalculate that when we change our member list. Otherwise, we'll just go through each member and render it. That's it. Oops. Okay, and when we add or remove members, we need to reposition them. And we call those just, we'll call a redistribute method here and here. Distribute. And what redistribute does, distribute is, oops, no, I deleted the stuff that I needed. Nope, that's not what I need anymore. Good thing I did not. Wait, no, it's not the load balancer that I need. I need the simulation. No, I need my own thing. Yeah, that's the logic here. So now we recalculate the positions of our elements. So member space, they need to share 800 pixels. We'll simply use member count. Nope, nope, not what I wanted. And member offset. And now we simply go through all our members. Members each pair do ID member and we'll say member what? Wait, where's main? Here's the formula. We need an index. That's basically member pos x. Let's just call it offset. The context is pretty clear, so thing is, we need an index. Guess we'll have to do that manually. Member pos y is basically our own pos y. Because yeah, if our cluster will be rendered horizontally, then it at least needs a y position where everything will be aligned. So that's something that we'll have to pass in. So that's what happens here. We'll say at pos y equals attributes fetch pos y. Okay. And we definitely need a tick method that calls render. If that's not already part of entity itself. Nope. Interesting, it doesn't. Yeah, because it's not clear when render should actually happen, if there are things that happen before or after. So that makes sense, yeah. So yeah, we need to render ourselves, which means we'll simply render our members. Yep. And maybe we want to draw a border around everything or something like that. So we can decide that later. That will then also happen in render. Okay. That does make sense to me. Which means we could change our simulation now and simplify it, because everything regarding positioning of cluster nodes now has moved into the cluster class. Here it says create receivers, which might not be appropriate anymore. And we'll also won't have to deal with a list of receivers anymore, I think, because our cluster can actually return a member list. So let's make that a public method. Member list will still be simply be members values. That way it'll return an array of all the member objects, which is the same as our receivers array that we are creating within this loop. So instead of working with an empty array here, we'll simply say cluster equals network cluster new. We'll pass in self because we are the model, and then we'll pass in a pos_y, which is, as you can see down here, 500. And that's it. We don't need this calculation anymore. Receiver count is the static method down here that simply returns a number. So we'll still use that. And then, yeah, we'll create a receiver for which we don't need a name anymore. We don't need a POSX anymore. That will be recalculated automatically, so we can get rid of that. It doesn't need a pos_y. That's determined by the cluster 2, and it'll just have a processing time, and that's that. We don't add this as an entity to the simulation. Instead, we'll do cluster, add member receiver, which will automatically trigger the redistribution every time we add a member. In the end, we'll simply return not our created array, but instead clusters member list. And we do have to add the cluster as an entity. So wait, let's go back. Shit. That's that. And yeah, add entity. How does that work? Add entity is part of simulation, of the simulation engine. We'll simply pass in an entity, so it's actually where's our simulation? Add entity cluster. And now it says superclass mismatch for class round robin load balancer. What does that mean? App network Dragon Ruby does not exist. I think something got confused, so let's try and restart the simulation. In main, create receivers, uninitialized constant model network. What? Yeah, I did not namespace this, did I? Did I? Wait. No, I did not. Is anything namespaced here? No. I probably should have put everything in the network namespace. That's another refactoring coming up. So instead of a network cluster, it's just a cluster. But that still failed. And it keeps failing in main RB86. Where we tick. Okay. What's going wrong here?
It's a Unix system. I know this.
Data science, welcome to the stack. This is supposed to be pretty straightforward, thanks to my object model. We create a cluster, we add receivers to the cluster, we add the cluster itself to our simulation, and return the member list of our cluster. Hi, data science, how's life? Thanks for joining us. Something's going wrong in tick, so our cluster just tries to render itself, which means it renders its members. Let's see, do we end up here? Puts render members. No. Now it still fails uninitialized constant model cluster. Okay, we are running into namespacing issues here. Not sure why we do now. We didn't before, did we? This should work. Looks like, it almost looks like an endless recursion here. Codespace, hello. Happy Thursday. Ooh, it's really warm. Let me open up the window a little bit more. Give this a little bit of a push. Yeah, we have almost 25 degrees in here. The window manager is GNOME, but I'm using the Paper WM extension, which is an amazing thing for a GNOME extension. It's basically an additional window manager that turns every workspace into a virtual canvas, and everything gets tiled next to each other if I don't tell it to stack, and I can simply scroll left and right infinitely, basically. So if I create a new window like this, no, this doesn't work for this. Let's create a new browser window. It'll simply open to the left, and then I can scroll back and forth with the keyboard or the mouse, and it works nicely. I'm really great fan. I've tried a few of these tiling extensions for GNOME, and they all worked 80% of the time. PaperWM does actually work very nicely, and I get updates almost on a daily basis, so the maintainer is pretty much on the ball. It's like Emacs. I'll have to admit that I haven't touched Emacs in about 20 years, but does... Oh, Emacs as a tiling window system? Wait, now you're confusing me. Is Emacs with a capital M something different than Emacs, the editor? If that's the case, it's really a confusing choice of name. Okay, so oh, you're talking about the editor and tiling window system. I'm still confused. I mean, I can imagine tiling your editor panes and stuff like that, but I do know that Emacs is an operating system. It's just lacking a proper editor. No, I'm confused as to are you able to manage other windows like your browser window? EXW. I'll have to look this up. Are you kidding me? Emacs X Window Manager is a full-featured tiling X Window Manager for Emacs built on top of XELB. Consider my mind blown. Really? Are you fucking kidding me? You can... That's... What? You can use Emacs as your X11 window manager. This is amazing. This is amazing. Of course you can. Of course you can. I did use Emacs as my main operating system back in the day when I tried to get everything done within Emacs. I used Emacs as my mail client, as my Usenet client. I didn't use it as my web browser though. But yeah, I can imagine doing a lot of stuff in Emacs, but using it as your window manager?
I know this.
This is beyond my imagination. And yes, there is a Discord. Join us if you like. We are a friendly bunch of people. And thanks for the follow. We also have a great community. It's a membership community with a subscription, but it's a great place to learn. It's not only a private and safe forum for people, it's also the place where we run lots of events for our community members. I'm definitely interested in getting you your money's worth there. And Patel, welcome to the stack. Thanks for the follow. I do appreciate it. Okay. How to find out what's happening if all we get is main RB in tick? I did add a debug message here somewhere in our... Didn't I? In render members? No? Did I remove that already? But let's add that here. In cluster.render. Oh, we're still running into the model cluster issue. Model cluster issue. Oh, I added the colons in front of... well, we'll need it in front of receiver as well, won't we? Let's see. Uninitialized constant cluster. Yes, that's because we need to include it in our network model or network class. Okay, running to some issue now. Okay. Okay, that looks better. Render wrong number of arguments in cluster 22. Render... wait. Yes, we need to pass in arcs, of course. And arcs, of course, needs to be available. And then it says render method missing on cluster. Cluster inspect. Wait, where doesn't exist on cluster. Let's restart. I think this might need a reinitialization. Nope, same issue. Okay. Method named render with args missing on cluster. I disagree. Codespace, thank you for the posture check. And I also need to make sure to empty my coffee before it's ice cold. I was wondering earlier why there's a slightly funky taste to my coffee today. It tastes differently, and I thought, well, I didn't change the beans, but I did change the oat drink that I'm using for my oat latte. That has a different taste. Picture of a desktop, simply send it to general, or there's also a show and tell channel where this would fit in nicely as well. Okay, so render cluster 24. Oh, we're trying to use to call super, and super doesn't exist in... Yeah, it doesn't. Maybe not every entity in our simulation needs to render itself, so there is no super class there. And now it says members method. In cluster 41, we call members each, and that needs to be our... Okay. I guess that's down here. That's supposed to be our cluster or something. The sender and the load balancer do work, and then the load balancer sends stuff off into the universe. Okay. So now we are in cluster render, but cluster render doesn't work. Oh, that's a pity. but that's something we can focus on now. What language is this? That's Ruby. It's Ruby, and it's Dragon Ruby in particular. Dragon Ruby is a game development toolkit. And yeah, I chose it because it makes building this kind of visualization / simulation easier. Another ad break is coming in, so I need to be sure not to talk into that. Otherwise, I definitely am a Ruby developer. Yeah. I've been coding in Ruby for 14 years now. And I love the language. Not that I'm opposed to anything else, but it simply fits my needs. And I love its syntax. It has a great community of perfectly friendly people. Okay, so render goes awry. Let's see. If we take a look at redistribute, here our members should be repositioned with every member that gets added to the cluster, and I think something is going wrong here. So let's add a puts here in redistribute, and that should get called 3 times. And we need to switch off the in-cluster render, otherwise stuff will scroll off quite quickly. There is no... Yeah, in redistribute 1, 2, 3, 4, 5, 6. That's far too many times. Huh. No, something's wrong here. Okay, let's give this another try. But yeah, these are too many redistribute calls. Add member. I think something is wrong in our main simulation setup here. We did create receivers. We're working based on receiver count. Wait, each time... Ah, yes, of course. I did not think of that. Of course, yeah. We're adding as receiver, redistribute is called for 1 member. Then we add another receiver, then redistribute gets called for the 2 members. Yeah, that makes sense. I did not think of that. We are creating a series here. So it's 1 plus 2 plus 3 plus 4, which is then in the end 10. Okay, that makes sense. Code space. You said you are C assembler and Java programmer and some JavaScript. I haven't looked into JavaScript too much. I needed it a few times in very simple web development, so I won't dare to say I am fluent in JavaScript. Of course, I do understand the syntax, and I'm able to adapt Stack Overflow posts, but that's it. I did do C and assembler in my more distant past, especially when I got my Amiga at the end of the 80s. I started programming C on that. I did assembler before that, both for the 6502 and a little bit for the 68,000 on the Amiga as well. But since then, I haven't done any assembler programming myself anymore. I did dabble in Java a little when was that? Yeah, I did a lot of Perl programming. I loved that language too, and did web development in Perl. And then I thought, let's try and find something more professional, shall we say? And I thought, yeah, but Java is all the rage, which it was back then. And I started getting into Java, but even just researching how to do web development in Java with Java server faces and Java server this and Java server that, I didn't get even into web development in Java. And I think I don't recall the correct order anymore. I think that was when I got into Ruby then, and things fell into place. And Patel asks about PHP. Is PHP dead? No, it's not. I mean, look at who's running PHP. Even Facebook was built using PHP. That's it's definitely not dead, and otherwise I would not have a job actually, because I own a company that specializes in managed hosting for high performance websites based on Drupal and WordPress, both being based on PHP. I'm pretty much dependent on PHP still being popular, and it is. PHP is still used in web development a lot, and it's very, very capable as well. And the language itself evolves all the time too. I mean, the PHP developers don't sit on their hands all the time either. So yeah, it's definitely still around. I won't claim it's the most enticing of languages anymore, but it does get the job done, and that's what matters, at least to businesses in the end. I mean, if you're looking for a language that you can learn as a hobby or for a job where you do that language, there are definitely languages that I would recommend over PHP. Ruby being the first one, of course. Python is just as capable. And I'd like to get into Go programming eventually, because that, as a compiled language, is definitely something that I'd be interested in. But there is strong competition by Crystal, which has basically the same syntax as Ruby, but is a compiled language. So I might actually explore Crystal before Go. But I'll still have to wait until I have the time, which is not in the cards right now. And Hanso, hi, welcome to the stack as well. Now, let's see. I did add a debug message to my adding receiver. Yeah, and then we found out why it initialized or it redistributed so a lot. Let's see. We can actually get rid of this. We can get rid of the debug statement in redistribute in the cluster. But I'd like to see let's format it correctly. Like this. So that we can see how it does redistribute stuff. And let's simply add that here, so we can see when the method starts. Okay, let's see. We are in redistribute and it says 615,500. That should work. Then it's 415,500 and 415,500, and that is because we don't increment the index. Now, 615,500, 415,500 and 815,500. Yeah, this looks much better. Stuff is almost correct. It's just, I think all their borders get drawn here at 0, 0 instead of where they belong. Otherwise, the positions are correct. The requests get distributed between our 4 cluster nodes. So this seems to work. There's just a slight glitch left in rendering the border of our receivers. I won't be able to contribute to the TypeScript discussion. I've never touched TypeScript. So let's see why our borders are off. That's pretty much up to the receiver to render correctly. Strangely enough, the labels are at where they belong. That works perfectly fine. Can actually get rid of the dropped counter. How can it be that the labels are positioned correctly but the borders aren't? That's in the endpoint class. We are moving up the class hierarchy in terms of abstraction. Here we create a border. Oh, the border only gets initialized once and is not able to move. That's of course not a good idea. We need to change that. And yeah, for the time being, let's move that here. It was better when border was just initialized once, because that kept us from recreating this object all the time, every frame. But the problem is bounding box will now not work anymore. Well, let's duplicate that then. It's not as efficient, but we can fine-tune for performance at a later time. Oh, I didn't notice the borders moved into place. Okay, our simulation is working again. We just don't accept any request anymore. What's going on? How does every... What? And why is there a busy in the endpoint? An endpoint, a generic endpoint, does not even have busy, so that can actually go, so which means we don't need the initialize method anymore either. And we don't need that anymore. What's with the... Let's see. Yeah. Some got through? Did the first request get through and then it started rejecting everything? Interesting. So I guess we'll have to track busy in here. Because that's where we, it's not 0, it's busy is false at the beginning. And oh, we are running into a big problem here. Are we? Thing is, our request wants to go to a specific endpoint. We do... return our member list, but we only do that once when we create the receivers. And so the load balancer has these receivers, which works. It won't work if we change the number of receivers mid-simulation. That we'll have to change. Exegete, hey! Good to see you. How's life? Okay, and we create the emitter with the load balancer. Okay, the load balancer still knows all its targets, and it sends incoming requests or copies of incoming requests to one of its receivers, and that's visible as well. And the request will then try and intersect with the receiver, which works too, as we can see that they bounce off. However, when we intersect, the hit method gets called, and then we call connect for this receiver. And each of these receivers seems to be returning false in connect, which only should happen if we are busy. Okay, we need to make our simulation a little bit more debuggable, which means we'll set our spawn rate to 30-30. So we get slow requests. As you can see, the round-robin algorithm does work. But for some reason, our receivers don't accept any requests anymore. Okay, let's also reduce the number of receivers to 1. Yeah, we had 1 successful connection and then things went south. What did I change here? We enter...
Flush the bombers, get the subs in launch mode. We are at DEFCON 1. DEFCON 1?
Drago, welcome. Hello, Raiders. Use the attack command if you'd like to. We'll use the defend command to defend ourselves. Drago, how's it going? Thanks for the raid. How was your stream? What did you do? I guess I should debug here in connect. Yeah, that works. And let's output busy. Busy is true. Yeah, so the whole busy animation is missing. I think it's because the cluster is some connection broke. No idea what you're doing? Don't worry about it. I've been doing this stuff for years and still sometimes don't know what I'm doing. But I do hope you had a good time doing something that you don't know what to do. Okay, how does my busy thingy work in the first place? We do handle the busy state. And in busy state, we render the busy state. Where the receiver does... Okay. Are we in constant busy state here? No. Python makes you confused? Yeah, I'm doing Ruby. I've been for a long time. And since I'm using the Dragon Ruby game engine to build my simulation here, yeah, that's Ruby too. Well, it's actually the other way around, of course. I was looking for a framework that allows me to graphically render stuff on screen that I could do in Ruby, where I wouldn't have to learn a different language, such as JavaScript. And thankfully, Dragon Ruby is around and very capable. So we are in connect. Busy is true. Let's remove that then. We are in tick. We do handle the busy state. Do we that though? In handle busy state. And let's output busy. We're not calling handle busy state, apparently. And that's because tick doesn't get called. We don't call tick of our receivers anymore. We render our cluster, which means we render our members. We call render on our members, but we don't call tick. So we need yeah, you know what? The cluster itself doesn't even render. Do our receivers render themselves in tick? Yeah, they okay, so that's my mistake. I was bypassing the tick method and was basically short-circuiting everything, going right into render, which got them displayed, but not updated and anything. So yeah, and since our cluster doesn't do anything visually, other than just rendering its members, I think we shouldn't have a render method in the first place. We should have a tick members. We don't need that. And instead of render members, we'll do tick members, where we call tick for each member. And now everything works. And handle busy state can lose the debug message. Okay. And now the success rate of our receiver is going up slowly, because yeah, with 27, it's a little bit faster, just slightly faster than our spawner, which runs with a min and a max of 30. So actually, after processing a request, it has 3 ticks left to catch its breath. And so it will eventually approach the 100% mark. But because we were losing so many requests before, that will be very, very slowly. Okay, our cluster is working again. Now let's visualize a more complex cluster. Let's end this and go back to our simulation, where we say let's have 3 receivers and our spawn rate between 10 and 30 ticks, which is a little bit more ambitious, but with 3 receivers there are drops. Some of these requests come just too fast for our receivers here. With a spawn rate between 10 and 30 and processing times of 33, 44 and even 53, those application servers are a little bit too slow. Let's randomize those values. Okay, we have a very fast one here and a very slow one over here. So this one will always have 100% success rate, because with 10 it can handle even the fastest burst of requests, and the other ones might not. Ooh, even that one dropped 1 or 2 requests now. I wonder why that is. How is that possible even? I think my spawn rate calculation might be off. No, it might. No, it can't. 10 is the minimum. That is definitely... strange. Okay, our cluster works. I mean, we could draw a rectangle around our cluster as well, if we wanted to. More importantly, I would like to be able to add machines on the fly and see the cluster redistribute them. How is this set up yet? Now, receivers. The load balancer can't add backends dynamically yet. So that's something that we'd have to include as well. The only thing that I'm getting afraid of is that eventually I'm actually building a virtual load balancer and a virtual proxy cache and a virtual whatever, because I'm adding all these features just to see my visualization here. Anketil, welcome to the stack. Okay. The to-do list keeps getting longer. Now I'll have to be able to add backends on the fly and maybe even remove backends from the load balancer too. Yes, of course. If we want to shrink the cluster, we need to take them out of the load balancer as well. Otherwise, it'll keep distributing to a machine that isn't there anymore. Amazing. All right, but that might be for another time because, yeah, we are almost at the end of our stream. I'll lean back and wait for the ad break to end. I mean, what we could do is add nodes to the cluster. It's just that the load balancer won't learn of this new node, but it should display on screen. The load balancer will not distribute requests to it, but that should work now that we've rebuilt this cluster entity. We could do that. Codespace, welcome back. Let me try that quickly. There are still a few minutes. We could go into cluster. Oh, no, that's not in cluster. We will have to do this differently. We'll have to keep track of our cluster here. What we'll do is we'll change a few things so they are named more appropriately. For example, we'll call create receivers, create cluster. And at the end of create cluster, we'll return a cluster object. So we'll return cluster itself. which means this is cluster, and the load balancer will get the cluster's member list. Okay, with this change, stuff should still work nicely. Let's restart our simulation just to be sure. Yep, okay. But now I can actually store this in an instance variable of my model. And why not do the same with the load balancer? And well, let's leave the emitter as it is right now. We don't need a handle on that. And actually, if we don't need a handle on the load balancer yet, we need it next time when we build the dynamic change of load balancer backends, but oof. Sorry to hear that, Codespace. That's always annoying when your GUI crashes. Okay, now we have a cluster as an instance variable, which means in my engine's tick method, which isn't specifically defined yet. Ah, interesting. Okay. So in our specific tick method, we'll have a super call here. That again should not change anything. And now we could do something like we do down here. We use args inputs keyboard. In our tick method. Is that our new tick method? Why does it turn into tick count? And we could say if our tick needs args as an argument, tick always gets called with args. If args input key down, let's call it A for add. And then we'll add another receiver. So I guess we'll extract this part here. Into add receiver. That way, actually we don't need... Oh yes, we do have to have a cluster. Okay. Yeah, okay, fair. And in our tick method, if A gets pressed, we'll call add receiver, add cluster. Wait, what are the other arguments? Go to declaration, add receiver cluster index.
Flush the bombers, get the subs in launch mode. We are at DEFCON 1. DEFCON 1?
So many raids, Bright Jess. Hey Jess, how you doing? Welcome, raiders. Welcome to Full Stack Live. I'm Jochen, the Monospace Mentor, and I'm happy to see you. Use the attack command if you'd like to, and as regular viewers here, we'll use the defend command and we'll see what happens. Jess, how you doing? What did you do today? I'm building a visual simulation of network services. As you can see, I have a client here that sends requests, sometimes in bursts, sometimes with bigger pauses in between. They go to a load balancer, which then distributes these requests between 3 nodes. And at the moment, I'm building another feature that allows me to add more nodes to the application server cluster up here dynamically. So things can scale up, and we can see how many of these requests need to get dropped if we increase the number of application servers. Because as you can see, once an application server is busy processing a request, it can't accept any more requests, and those then get dropped and bounce off. I'm building this simulation with the Dragon Ruby game toolkit, and I'm having lots of fun doing it. Part of the fun is seeing how things are actually visualized on screen and see stuff bounce and do all kinds of stuff. And the other part that's really fun, and I guess that is me being a software engineering nerd, is building an object-oriented design that models this simulation where we have clusters and endpoints and receivers and round-robin load balancers and stuff like that. Nori, welcome to the stack. Good to see you. She left you behind. How could you, Jess? You were working on Unity? Hope you had a lot of fun too. All right, so where were I? I wanted to add another cluster, and now I realize we need an index. How? Wait, what? Oh, processing time index. Okay. Actually, let's drop that. Let's not make processing time use index in the first place. So, just to make things easier, if we need some kind of an index, we can generate it on the fly. That means we can, when we build our simulation, we can simply call add receiver without having to track an index at all. So we can make index. Actually, you can drop this variable completely. And when we press A, we can simply say add another receiver to our cluster. Okay, now let's stop our simulation. We are starting with 3 cluster nodes. Let's see what happens when I press A. Hopefully it won't be a crash. It isn't. We can add more cluster nodes on the fly now. Unfortunately, our poor load balancer here doesn't know that. This load balancer is still... Oh, I need some more coffee or something to hydrate. That's my coffee done now too. The load balancer still works under the... Thank you, Kurt Space. Thanks for the support. The load balancer still works under the impression or under the assumption that it only has 3 backends. As you can see, it sends its request only to the first 3, and the 4th one that I just added doesn't get used. And if I press A another time, we get another cluster node, and unfortunately those requests still go to nodes 1 to 3, and 4 and 5 are empty. So we need to tell or to teach our load balancer to adapt its backends dynamically, but that is something that I'll do another time, because it's 5 o'clock here, and that means I've been going on for 3 hours, and yeah, I can use a break. So, folks, let me make a few recommendations for you. If you'd like to continue the chat, feel free to join our Discord. We are a friendly bunch of people, and we love to talk about all kinds of stuff, mainly dev and ops. And if you'd like to seriously boost your skills and careers, then take a look at my community called The Server Room. With a subscription that starts at €5 per month, you can join this community. And not only do we have a great community platform where you can find all kinds of DevOps knowledge and ask your questions in a safe space, we also do a lot of community events. Go to theserverroom.sh to find all the details. And join us for example, the upcoming community hangout in May, or the deep dive that I'm going to do on my Linux setup here on my workstation, or even to join the upcoming community workshop, where we are going to build a statically generated website running on a cheap VPS with SSL from Let's Encrypt and easy deployment using Git. This workshop will be guided by me. I'll provide tutorials, I'll provide the VPS access and everything, and I'll guide you through the whole process. So if you'd like to learn practical system administration and maybe even get to the point where you can easily run your own website on your own infrastructure, that's also going to be something that you'll learn when you join the server room. So yeah, it's Thursday. That means tomorrow is going to be my office hour at 2 p.m. Irish time, or 12 p.m. UTC. My office hour is where I answer your questions. I don't have to prepare anything except for getting all kinds of questions, and I'll do my best to answer them. So if you have any questions about system administration, about Ruby coding, about software engineering in general, or what to do with your life, then pop by and say hello and ask your questions, and I'll do the best I can to get your questions answered. That's it for today. I had a lot of raids. Thank you for all the raids. Let's see. Jess, Drago, and where is the other one? That was TBD Gamer. Thanks, everyone. And I hope to see you tomorrow to my office hour, or next week. No, I won't see you next week apart from my office hour, because next week I'm going to be at DevOps Days Berlin. I'll try and live toot from there on my Mastodon account, or maybe even on our Discord. And so we'll see each other again, I guess, next Friday for another... No, tomorrow for the office hour, and then next week for another office hour. And let's see if we can rate someone ourselves. Let's pay it forward. Who's online at this moment? Yes, there's Shell Codes. Let's go and raid Rachel's channel. Another great Ruby coder. So yeah, thanks for everything. It was a lot of fun, and I'll see you soon. Take care.